Hello everyone and welcome to Kingsheart, your choices tutorials. Today we are going to learn about organic compounds. What are organic compounds, you may ask? Well, they are very important molecules that make up living things such as plants, animals and even you and me. They are also found in many things that we use every day, such as food, clothes, medicine and fuels. Organic compounds have one thing in common, that is they contain carbon atoms. What is this carbon atom? Carbon atom is a very special element that can form four bonds with other atoms. This means that carbon can make many different shapes and structures with other elements such as hydrogen, oxygen, nitrogen and more. We call this property of carbon tetravalency, which means having four valency or bonds. Carbon can also bond with itself to form long chains or rings of carbon atoms. We call this property of carbon catenation. I've mentioned two properties now, tetravalency and catenation. Don't forget it. Because of these properties, carbon can create a huge variety of organic compounds with different properties and functions. Let's go further. Now, how do we name and classify these organic compounds? Well, there are some rules and systems that we use to do that. One of them is called the general formula, which tells us how many atoms of each element are in an organic compound. For example, the general formula for alkanes, which are a type of organic compounds, is C subscript Ne H subscript 2n plus 2. Don't forget those subscripts, where n is the number of carbon atoms. This means that for every carbon atom, there are two hydrogen atoms plus two more. So if we have one carbon atom, we have four hydrogen atoms, and the carbon is called methane. Another example, if we have two carbon atoms, we have six hydrogen atoms, and that carbon is called ethane, so on and so forth. Another system that we use to name organic compound is called the IUPAC nomenclature. What does IUPAC stand for? IUPAC stands for the International Union of Pure and Applied Chemistry. This is a standard way of naming organic compounds based on their structure and function. For example, the IUPAC name for methane is methyl hydride. What does that tell us? That it has one methyl group, and you know that your methyl group has a carbon atom and three hydrogen atoms attached to it. So what does methyl hydride tells us? It has a methyl group and an extra hydrogen and extra hydride group. We have ethane. The IUPAC name for ethane is ethyl hydride. That has two methyl groups and one hydride group. More examples will be given later on. Another way of describing organic compounds is by using the empirical formula. The empirical formula is the simplest ratio of atoms of each element in an organic compound. For example, the empirical formula for methane is CH4, that's CH subscript 4, which means that for every carbon atom, there are four hydrogen atoms. Now that we know how to name and describe organic compounds, let's look at some examples of different classes of organic compounds. There are many classes of organic compounds, but we will focus on some of the most common and important ones. The aliphatic hydrocarbons. They contain only carbon and hydrogen atoms, and they have three subgroups: alkane, alkenes, and alkynes, based on their degree of saturation and number of bonds. Alkanes are completely saturated, which means that they have only single bonds in their chain. Alkenes are unsaturated, which means that they have at least one double bond in their chain. Alkynes are unsaturated, that means they have at least one triple bond in their chain. Some examples of aliphatic hydrocarbons are methane, ethane, propane, butane, ethene, propene, butene, then ethyne, propyne, butane. I hope you can tell the difference and hope you can differentiate it in the three subgroups I mentioned. Aromatic hydrocarbons. These hydrocarbons are organic compounds that contain a benzene ring or a derivative of benzene ring. Now, what is a benzene ring? A benzene ring is a hexagonal ring of 6 carbon atoms with alternating single and double bonds. Aromatic hydrocarbons have special properties such as stability, aromacity, and reactivity. Some examples of aromatic hydrocarbons are benzene, toluene, phenol, alanine, and naphthalene. Remember that why they are called aromatic is because they give off a very thick smell when they are bonds. Just put that somewhere. Another class of hydrocarbons that you should know are alkanols. These are organic compounds that contain OH group attached to a carbon atom. They are also called alcohols. They can be divided into three subgroups: the primary, the secondary, and the tertiary, based on the number of carbon atoms attached to the alpha carbon. What is an alpha carbon? That means according to this structure, the alpha carbon is the carbon that contains the hydroxyl group, that's the OH group. So some examples are methanol, ethanol, propanol, butan 2-ol, and glycerol, that is propan 1,2,3-triol. So Another class of organic compounds is alkanes and alkanones. These are organic compounds that contain a carbonyl group. What is a carbonyl group? A carbonyl group is a carbon atom that is doubly bonded to an oxygen atom. You can also call them alkanes, can also be called aldehydes, while alkanones can also be called ketones. Alkanes have the carbonyl group at the end of the carbon chain, while alkanones have the carbonyl group within a carbon chain. That differentiates the two of them. Some examples of alkanes and alkanones are methanol, ethanol, propanol, butanol, ethanol, propanol, pentathione, and so on and so forth. Another class of organic compounds is alkanoic acid. Alkanoic acids are organic compounds that contain a carboxyl group, which is a carbon atom that is doubly bonded to an oxygen atom and a single bonded to an hydroxyl group. They are also called carboxylic acid. They can be divided into 3 subgroups based on the number of carboxylic acid that has been attached to the carbon chain. We have monocarboxylic, dicarboxylic, and so on and so forth. So another one is some examples of alkanoic acids: ethanoic acid, propanoic acid, ethane dioic acid, citric acid, and so on and so forth. Then we have another one called alkanoids or esters. They are organic compounds that contain a carbon atom that is doubly bonded to an oxygen atom and singly bonded to another oxygen atom that is attached to an al group. That's an alkyl and alkyl group. An alkanoic acid reacts with an alkanol by a reaction called esterification, and hydrogen and water is released as a byproduct. Some examples of alkanoids are methyl methanoids, ethyl ethanoids, amine. These are organic compounds that contain an amino group, which is a nitrogen atom with two hydrogen atoms attached to it. They are divided into 3 subgroups. We have the primary, the secondary, and the tertiary, based on the number of carbon atoms attached to the nitrogen atoms. What does that mean? That if 1 carbon is attached to the nitrogen atom, we have a primary. 2 carbon attached to the nitrogen group, we have secondary. If it's 3 carbon, we have tertiary. They can be divided into aliphatic or aromatic amines based on the nature of carbon atoms attached to the nitrogen atom. Some examples are methylamine, ethylamine, butylamine, aniline, phenylalanine, and so on and so forth. Let's move on to the next section. Now we have carbohydrates. I know you might be surprised to know that carbohydrate is also an organic compound. Yes, carbohydrates is an organic compound because it contains carbon and hydrogen, and also hydrogen oxygen atoms in a ratio of 1:2:1. They are also called sugars or saccharides. They can be classified into 3 subgroups: the monosaccharides, the disaccharides, and the polysaccharides, based on the number of sugar units. Some examples of carbohydrates are glucose, fructose, galactose, sucrose, lactose, maltose, cellulose, glycogen. Then fructose. Then another class is protein. Yes, protein is an organic compound. I'm ready to shock you guys throughout this whole of these tutorials. They contain amino acid linked by peptide bonds. Amino acids are molecules that contain an amino group and a carboxyl group attached to a central carbon. There are 20 different amino acids that make up proteins. Proteins have a primary structure, a secondary structure, and tertiary structure and quaternary structure. Some examples of proteins are your enzymes, your hormones, your your hemoglobin, and so on and so forth. Now we have polymers. Polymers are large molecules that consist of many repeating units called monomers. Polymers can be natural or synthetic, and they can be formed by 2 types of reaction. We have the addition reaction and the condensation reaction. Addition polymers are formed by adding monomers together without losing any atom, usually water. While condensation polymers are formed by adjoining monomers together and losing small molecules such as water. Some examples of polymers are rubber, nylon, polyester, and DNA. By the end of this series, you'll be able to define organic compounds and organic chemistry, explain the tetravalency of carbon and its ability to form chains of compounds called by the process called catenation, explain the general formula, IUPAC nomenclature, and empirical formula of organic compounds, give example of different classes of organic compounds and their properties and functions. Wow. I hope you enjoyed this video and learned something new. That's the number 1 joy I have from doing this. If you did, please give us a thumbs up and subscribe to our channel for more videos like this. Thank you for watching, and I see you in the next video. Bye.